Okay, we've been spending a lot of time on integrals. This is the definite integral. And you learn that the integral a to b f of x dx is equal to, anybody remember? Very good. Big F of A minus big F of B, where big F is any antiderivative of a little f. What does that mean? Okay, that's kind of along the right lines. More along this, Jasmine, if you didn't have A or B and it was an indefinite integral, if we take the derivative of the right side, we get the left side. But when we evaluate it, we spend a lot of time talking about this stuff. What does it mean? Yeah, the area underneath the curve. That's what this represents, right? So the fact is we've been spending a lot of time doing these type of things. 0 to 1 of x squared minus 3 dx. And you learned how to do that. You just do x cubed over 3 minus 3x evaluated, 1 and 0, right? That's just the area underneath the curve. That's all it is. That's what we've been doing. Now, all of a sudden, we did this substitution thing the other day. It's like, well, why do we do that? Well, because on your last test, we gave you easy antiderivatives. We're done with the easy antiderivatives. Now it's time to kind of grow up a little bit, do stuff that's challenging. Okay? And we talked about the substitution piece. Well, today, what we're going to show you is just one last little tweak to it, and that's if you have substitution with bounds. Okay? Definite integrals. And what you can do is you can do a substitution. You can have a function in terms of u instead of in terms of x. But that changes your bounds. In order to compute what this bound is, you would say it's u of a. In order to compute this bound, it's u of b. Now, for anybody watching this video, I want to be clear that this is not necessary in order to evaluate integrals. You don't have to do it this way. But this is an AP Calc topic, as I like to refer to as the AP Cult. Sure, it's fun, it's cool, great, but do you have to use it as you move on? No, not at all. And so, is it essential to be able to say people are ready to move on from calculus? No, not at all. The reason why I cover it, it shows up on the AP exam. So, let's just see what it looks like. Super easy. Number 5, u is what? What's du? 2x dx. You have to take the derivative. Okay, do I have a 2x dx? No, I have an x dx. So I divide by 2, I get 1/2 du is equal to x dx. So my integral becomes 1/2 times the integral du. What remains? U to the 4th. Nothing new yet, right? Here's what's new. I'm going to change the bounds. Because I'm working with u, I'm going to change it. I'm going to plug in 0 here. 0 squared plus 3 is 3. And 2 squared is 4 plus 3 is 7. What's the antiderivative of u to the 4th? It'll be u to the 5th over 10 then when I multiply by the 1/2, right? Evaluated at 7 and 3. Now, here's what I always used to do. I wouldn't use u. I would use x squared plus 3. And I would evaluate it then from, what do we got here, 0 and 2? These are the same things. Are you convinced that they're the same? Okay, well, plug in 2 here. 2 squared is, whoops, sorry. Plus 3 to the 5th. You get 7 to the 5th on top, right? And here you get 7 to the 5th. They're the same things, right? So most people just continue to substitute u back in and do that. But on the test, I'm going to ask that for a section that you focus on doing it by substituting bounds. And so you have to know how you come up with the 3 and the 7. And now we evaluate. We have 7 to the 5th over 10 minus 3 to the 5th over 10. Those are some pretty big numbers. 7 to the 5th minus 3 to the 5th. And I get 16,564 all over 10. Divide top and bottom by 2, and you get 8,282 all over 5. And that is your area. Did I make a mistake? Okay. All right. Last example, we try number 6. What is u? Very good, Callan. Sine of x. What's du? dx. Do I have a cosine of x dx? I do. So I get rid of it, and I have the integral, and I have du. What remains? U to the third. Change my bounds. I plug in 0. Sine of 0, 0. Sine of pi over 2, 1. What's the antiderivative of u to the third? I'll evaluate it, 1 and 0, and I get 1/4. It's kind of cool, huh? That's it. Okay, so Kelvin just said very easy. I do want to make it clear that past history shows that only about, I would say, 2/3 of students actually get these problems right on the test. And yeah, they're not tough. People just say, well, I didn't know. Here's what people do. They'll do u to the 5th over 10. Instead of doing 7 to 3, they'll do 2 to 0. Or they'll do x squared plus 3 to the 5th over 10. Instead of doing 2 to 0, they'll do 7 to 3. Or I actually have people, they'll actually take this thing, they'll multiply it out 4 times, distribute this through, and then take the antiderivative. And it's like you're not using substitution at all. I don't know why, but as soon as I just write the directions to say, please use the substitution rule and substitute your bounds, people just start making stuff up. This is all we're doing. Okay. Let's keep it simple.